All right, this is our last lesson in our angle and parallel lines unit, and this is where a lot of the stuff we're doing is very similar to what we were doing before. There's quite a bit of terminology in this lesson. I'm less concerned about the terminology and more concerned about can you figure it out? Okay, can you understand the relationships here? Because lots of these have more than one way to figure it out, and the actual names of these things I don't think are things that most people use in their even in your trade, but the skill of like understanding these angles and calculating some things and estimating these things is absolutely something that is used all the time. So uh, this is just review where we were saying, where we are looking for these missing angles, and all these we were figuring out either by knowing that like a pair of angles here where you've got a straight line that's being split into two angles. Okay, together those have to add up to 180. So we would know that like 85 plus what is going to give us 180. It'd be 85 and 95 together would give us 180. The other thing we were using in the last lesson is that anytime you've got like an X like this, where you've got two perfectly straight lines crossing each other, angles that are directly across from one another, okay, they're like on opposite sides of the X like that, they're going to be the same. Okay, this one is also going to be 85, same as that one. And these two are directly across from each other, so this one's going to be 95 as well. You could figure these out without that relationship. You could just know that like these two have to add up to 180, and these two have to add up to 180, and these two have to add up to 180. It's just a little bit more work. Okay, and same thing for down below here. 112 plus what gives you 180, and so on. Okay, this one's a little bit messier. This one is just trying to, this one uses 90-degree angles. Okay, that like this here is a 90-degree angle, so 70 and this together, and 20 would make a 90-degree angle. And then it has this one here, also is a 90-degree angle. This one and this one have to add up to 90. Okay, so some definitions here. Parallel lines you do need to know. Okay, parallel lines are two lines that are going in the exact same direction, which means they will never cross. Okay, this is train tracks. Train tracks are going in the exact same direction. Their angle is not off at all, which means that they never cross over. They're just going straight beside each other forever and ever. Okay, those parallel lines are lines that go in the exact same direction and they never, ever, ever, ever cross. If I could draw straight lines, that would be helpful. And the way that we show this is by drawing a little arrow on lines like this. This means that these two lines are parallel. If I were to draw another line here, like that, okay, we would know that these two lines are parallel because they have this little arrow symbol. They're going the same direction. This one does not have that arrow symbol, and it clearly is not going in the same direction. So these two would be parallel lines, and that one would not be. Corresponding angles is basically like matching angles. Okay, when you have parallel lines, you end up getting these kind of matching angles, and I'll show you why that kind of happens. Okay, so I'm going to actually draw some straight lines here. So if I've got some random line here, say like that, okay, and then I've got another line that's going to cross over it. I'm going to make this line go like perfectly straight across. Okay, so right like that. So I've made 4 angles here. Okay, I've made an angle here. Draw not straight lines anymore. Okay, I've got an angle here, angle here, angle here, angle here. Now, it does not matter at what height I draw this line, as long as it's the same angle, okay, it's going to make as long as it's coming in the same direction, it's going to make the same angle here. Like if this was, let's say, if this is 100 degrees, this would be 80 degrees. Okay, if I take that line and copy it here, if I took that exact same line and I just shifted it upwards, I have not changed that angle at all. Okay, I've just like moved it upwards, but this here is still 100 degrees, and you can see this like these look exactly the same here. This is 100 degrees, and this one is still 80 degrees. And on the other side, it works out the same. This one is 80 degrees. This was 100 degrees, and this one is going to be the exact same, 80 and 100. So we can use this relationship to solve some problems. So what I mean by that is like, if I know that this angle's 80, like this top right corner here, then I know that the top right corner of this one's also going to be 80. Or if I knew that this bottom right corner here was 100, I know the bottom right corner here is going to be 100. And that is because these two lines are parallel. Okay, they're coming in at the exact same angle, and so when they cross, they're going to make the same angles. So down here, it says like which of these angles are corresponding. Okay, when it says corresponding, it means that or what we just showed, that they are a match. They are two angles that are like in the same position here of like top right, top right. Those are corresponding. They're the same. This bottom right, those are corresponding angles. They're going to be the exact same angle. So here it says like state which angles are corresponding in the diagram. Well, let's say here's my top right one. Here's my top right one. 1 and 6 are the same. Okay, those are corresponding angles. And this like top left and this top left, those are going to be the same. Okay, so like 2 and 5, those are corresponding angles. 4 and 7 are corresponding angles. And 3 and 8 are corresponding angles. Okay, I've done these the same color because these are also the same angle. Like if this is, let's say that's 80, this is also going to be 80. Okay, because these are across from each other, they're an X. And these are across from each other, they're going to be the same as well. So 1 and 6 are a match, 4 and 7, 2 and 5, 3 and 8. Those are all corresponding angles. So what happens now is we can solve for angles like this that we do have nothing next to, because in this question it says that line 1 and line 2 are parallel. Okay, so this line and this line are parallel, and it says find out angles like 1, 2, 3. Okay, so 2 and 3, that's like a review. Okay, 122 plus something is going to give us 180. So in this case, it is 58 degrees, and this one is also 58 degrees. But this one, we have nothing next to. We can't use our old tricks. This one, we need to know that because these are two parallel lines, these corresponding angles, this angle is in that exact same position as this one. Okay, it's like taking that line and just shifting it down over to here, makes that exact same angle. So this one here is also going to be 122 because it's corresponding. From that, we could also say that like 58 here is a match for right here. That one's also going to be 58 here. The question doesn't ask us for that, so we don't have to, but just by being given this one angle, we can figure out all 4 of these ones and all 4 of those ones. All right. I'm quickly going to explain this. I don't care about like the written out definition so much. And you can figure this stuff out without using these terms, but here's the general idea. Alternate interior angles are when you have two parallel lines and you've got a line crossing them like that. Okay. Alternate means opposite sides, and interior means like on the inside. Okay, so on the inside of these two parallel lines, on the inside here, on opposite sides. So I'm going to call this one X and this one X. Okay, these are on alternate sides, opposite sides here, and they are on the inside. So the interior. These two angles are the same. Okay, when you get this like Z shape here, those are called alternate interior angles, and they're the same. And you can see here that this angle and this angle are the same, like they make the same size. This angle here and this angle here also make that same size. This one I'll call, I don't know, let's call it Z and Z. Okay, these two are also the same, this one and this one. So that's alternate interior angles. Alternate exterior angles is exactly what it sounds like as well. Okay, they're on opposite sides because they're alternate, but exterior now means they're on the outside. So if we have two parallel lines, I've got a line going through them, we call this line the transversal. On the exterior, so now we're talking about on the outside, not on the inside here, on opposite sides. So I'm going to say call this one X and this one X. Okay, they're both on the outside of this thing, and they're on opposite sides. These two angles are the same. And these two angles here, ZZ, you can see that these are similar size, alternates. They're on opposite sides, and they're on the outside. These two are a pair of the same. Okay, why I don't really care so much about the terminology here is because you can figure all this out by what we just did. Okay, using this exact same thing we just did, if you didn't know about this at all, you could figure all these things out. Why is that? Well, because if this is a, let's say, 110-degree angle, okay, we know that this one is like the match for that, right? It's both like the top left here of our two angles. So you can figure out that this one is 110. That means you can also figure out what this angle is over here. One, it's directly across from it, so it's going to be the same. Or you could think of like these two have to add to 180, and then these two have to add to 180. Either way, you're going to figure out that this one is also 110. Okay, so when we're seeing this alternate exterior angles, all we really did here was just skip this step. Okay, we know that these two are corresponding, and then these two are opposite of each other, so the same. And so this is just skipping a step and just saying the two on the outside are the same. And this is also the exact same relationship, skipping a step, but the two on the inside are the same. Those two on the inside are the same. Okay. So some of these examples can get somewhat tricky. So you need to be careful. This one here says, find the pairs of parallel lines below. Okay, so parallel lines are the ones where they have corresponding angles. So like this angle here and this angle here are going to be the same. So if we can find corresponding angles here, that means we have two parallel lines. Like this angle here and this angle here, they're both the bottom right and they're the exact same angle. So that means this line are parallel. If we keep going, okay, we will find that this one, clearly this is bigger than 80, so I'm not even going to try. These two look similar. So if I could find out what this angle is, I would know if they're the same. So 100 plus 80 would give me 180, so that's what this one is. And this angle here, bottom left, are the exact same. Those are corresponding angles. So that means that this line here and this line here is parallel. I'm going to do two arrows there to kind of show that they're different than these ones here. And I believe that is it for this one. Anything else here, anything else you find here, the like top left, they end up not having the same for their corresponding angles. And that's it for examples on this one. So go slow on this stuff, be cautious, and estimate your angles, make sure it makes sense. Good luck.